Okay, so this was number 18 on the 10B and then 14 on the 12B. So we want to find the number of different remainders can result when a number to the 100th power of integer is divided by 125. Okay, so we are looking for something like this. We have some number to the 100th power, and then we have different result if I take the mod 25. 125. So the one thing I'm going to remind, because this is a good application of the Euler's theorem. So the Euler's theorem is like, let me write down. So the Euler's theorem, one of the most like common, I believe, stuff that we use, the Euler's theorem with the modular arithmetic. So that should be, that states that when you have like two numbers and they are just relatively prime, another way of saying that GCD is 1. Okay, so let's say GCD of like a and like a number, let's say P. So if this is 1, okay, when this is the case, then when you take an integer n, right, to the Euler's torsion function, which is going to be like this way, the Euler's torsion of that number, okay, so which is like P in my case, is equal to, I would say, congruent to 1 when you take mod P. Okay, so like if this is kind of complicated, so it's just basically telling us if you take the Euler's torsion function, which is something we need to know how to find as well, and when you take that as power of the integer, and that power will be congruent to 1 when you take the mod P. Okay, so that's basically what we have. So in our case, like we are trying to say we are looking for some like x, maybe n I just use anyway, to the 100th power. This is gonna be 1 when you take mod 125. So we just need to know the Euler's torsion with 125. So how we find the torsion function? So if I want to say this is the torsion of 125, you take the prime factorization, so which is 5 cubed, and then subtract the one lower exponent of 5, which is 25, right? So that will be 100. So the torsion of 125 is equal to 100. The meaning of this, there is 100 numbers that is relatively prime to 125. This is the short way of finding number of like numbers that is like relatively prime to any given number. So we have 100 numbers that's relatively prime to 125. So which means if I take any of these like numbers to the 100th power, so that will be congruent to 1. So we already have 125, like 0 through 124 is our remainder, right? So 0 through 124. So we have 125 different remainders, but we have like of those 125 numbers, the 100 of these will give us the same remainder, which is going to be 1, because any number that is relatively prime to 125, that will give us 1. For example, if I take the 3 to the 100th power, so this is congruent to 1 if I take mod 125. Or if I take the 7 to the 100, so this is also 1. So you can just keep writing any number that is relatively prime to the 125, that will be 1. So which means we already have like 100 of those numbers to be 1. So meaning that these two cannot be answered, because we have only 25 other to check. We can actually may have this as well, but we'll see. So the reason I said this may not be the case either, because when you look at the other numbers, let's say like multiple of 5s, like 5, like 10, 15, all the way to the like 120, 125. So these numbers, which is like 25 of these, are not relatively prime to the 125, which is the 25 of these, right? So if I take the, like, let's say 5 to the 125, or 10 to the 125, or any of these numbers to the 125th power. So this has 125 5s in it. So if you divide by 125, that will give us a remainder of 0. all of these numbers will be congruent to 0 when you take mod 125. So meaning that they are going to be having just one distinct like remainder, which is 0, and then all other 120, like 100 numbers, like 100 of these numbers will give us a remainder of 1, and then 25 of these numbers will give us a remainder of 0. So we do have only two different remainders. So that is the choice speed. So this question was, again, it's slightly challenging, but when you know the Euler's theorem, so it's kind of easier. If you don't know, you can still like take the power of like some primes, like 2s, 3s, and just kind of find some patterns. So that might still help, but I think the Euler's theorem is to go with this problem. Anyway, so I'll see you in the next video.